So we're going to walk through the frequently made mistakes for assignment 3B. Please make sure you document your code. Please make sure that you also add the appropriate type qualifier for the permit count, whatever you happen to call it. If you don't have that, then it's possible that the values of that field will be cached in different processor cores, which will cause no end of headaches. Please don't use atomic integer field updater. You don't need it. You just need to use an int with the appropriate type qualifier. Looking at the constructor for fair semaphore CO, please make sure that you don't create a fair reentrant lock. It's not necessary. We're handling fairness through the specific notification pattern. You don't need to call new condition on monitor lock. We're not using a condition object in that particular way. We're using it in a totally different way with waiters. And you also are missing something important here, which namely is the initialization of the wait queue. So don't forget to do that. Those kind of problems should be caught if you run the unit tests and the integration tests. There's no need to add another constructor to the class. It's not used, so please don't add it there. There's a couple of problems with acquire uninterruptibly. Make sure that you take a look at the frequently made mistakes video for assignment 2B for some hints on how to implement that properly. This is way too sparse. This code is sort of at the other end of the spectrum. It's way too complicated. There are things here that aren't necessary, but there's some things that are missing too. So make sure that you use a loop. Acquire uninterruptibly should be very, very simple and just have a loop that calls acquire. If you acquire, you're done. If an interrupt occurs, you set a flag. And when you finally break out of the loop, you check the flag and you basically go ahead and interrupt the thread if the flag was set. There's no need to do anything with fields like available permits. You don't have to handle that. That's handled in acquire, which you should just be calling. There's no need to handle the interrupt method in the interrupt catch clause. That should be at the end of the method. And there's no need to have the finally method here in a loop. That won't help you either. Moving on now, let's take a look at acquire. Please don't make changes to methods that don't have to-do tags. This particular method is going to do three things. It checks to see if the interrupt has occurred and bails out if it has, or if the thread's been interrupted. It then makes a call to a method called try to get permit, which, as we'll see, will try to get the fast path or the happy path result, which occurs if there's nobody in the queue and the permit count is greater than 0. And if neither of those conditions hold, then it calls wait for permit. And that's going to do the heavy lifting, as we'll see here shortly. The try to get permit and try to get permit unlocked methods are designed to do some clever factoring, which is called the thread safe interface pattern that appears in the Posted To book. You can also get it on my website because I wrote it about 25 years ago. And basically what happens here is try to get permit does the locking and then calls to a method that assumes that locks are held and does the business logic. So there should be no business logic really in try to get permit. Moreover, try to get permit is clever in that it will release the lock, the monitor lock, only if it gets a permit. In that case, we're done. If it doesn't get the permit, it keeps the lock held. And that way, when wait for permit is called, we don't have to reacquire the lock and check to see if the permit is available. So it kind of optimizes things. And it takes advantage of one of the cool features of reentrant lock, where you don't have to have fully bracketed semantics for acquiring and releasing it in a scope. Please don't mix and match synchronized statements and reentrant locks. We don't need the synchronized statements here at all. So this that'll just get us into trouble. And again, this code is really too complicated. It doesn't have to be quite this complicated. There's no need to have a local variable called permit available here. Just try to get permit unlocked and check the return value of that. And you don't need to have a catch clause, nor do you need to have a finally block here. One or two more things about try to get permit. Keep in mind that you don't want to have business logic and try to get permit. You just want to have the locking. So this code doesn't have any locking in try to get permit, but it does have the business logic. So that should be factored out into try to get permit unlocked. And this particular code here is making some additional calls. It doesn't need to. First of all, it shouldn't be calling. It should be forwarding to try to get permit unlocked, but also there's no need to call acquire. There's no need to call wait for permit. Those calls are called in different ways by other parts of the code. Now let's go ahead and take a look at try to get permit unlocked. The check here needs to be a little bit better fleshed out. needs to also take a look at whether the wait queue is empty. And there's no need to call wait for permit. Again, that's called in a different path through the code. And there's also no need to have a catch clause. Down here, this particular check doesn't have to be here. It needs to be fleshed out more. So you need to check more than just whether the permit count is greater than 1. And this code doesn't belong here. It belongs in try to get permit. The locking doesn't belong in try to get permit unlocked. Okay, now that we've gotten through those preliminary methods, let's talk about the really complicated method, the wait for permit method. This is the method that implements the specific notification pattern that Tom Cargill talks about in his article from many, many years ago. It's hard to believe how long ago. I think that was 1997, perhaps. So it's been about 25 years, and it's still good reading to this day. So again, please don't mix synchronized blocks or synchronized statements along with rantrant locks. We don't need to have that. And also, you'll never need to decrement the permit count field in wait for permit. That's handled instead in the release method, as we'll see here in just a moment. This particular code for wait for permit is unnecessary. You don't have to check if the permit's less than 0. That should be handled elsewhere. Also, please get in the habit of not calling the lock method within a try-catch block. That should go ahead of the try-catch block or the try-catch finally block. Please don't call the add last method without putting it in a try block. And right after that succeeds, you should have a finally block that unlocks the monitor lock, because otherwise bad things will happen. And so if you go down here, there's some other issues. Don't call remove. In this part of the code, that remove call should be done in the catch clause for interrupted exceptions. And so that code is sort of in the wrong place, although it's kind of the right code, just in the wrong place. And this lock should be unlocked much earlier, basically up around here in a finally block. Down here, this code, there's no need to check if waiter m released is true in an if statement. Instead, use the while loop underneath here. That's the right place to put that. That's where the await call will go. And this is not the right way to handle interrupts. With interrupts, you don't want to be adding anything. You want to be trying to remove the waiter from the wait queue. And if you, under the right circumstances, you want to release the permit. So you have to think about that. It's not too hard. I think I talk about it in my video. And then there's some issues here with calling unlock. It's being unlocked multiple times, sort of in the wrong place, and is not what we want. And this code here doesn't belong here at all. We don't want to be calling that code there. It needs to go earlier. And you also don't want to be calling await uninterruptibly, because the whole purpose of this method is to support the case where interrupts occur. So you want to be able to support interrupts. Let's take a look down here. Now we're getting into some real subtle issues. This is what you'll learn when you read the Tom Cargill article carefully about specific notification pattern. You need to first lock the waiter lock and then lock the monitor lock. So don't do them in the reverse order. Do them in that order. And then you'll also end up releasing the monitor lock earlier as well. Don't use a while loop here. You don't need to do that. And this, you do need to call await in a while loop, but that's the wrong condition to use for that. You want to be using the M release field on the waiter instead of permits less than 0. The call to remove should go in the catch clause. It should also, you should also check the return value and take the appropriate action. So depending on what the return value is, you'll call the release method. So you have to make sure you do that. We make this in Java mode so it's colorized better. And again, you never need to decrement M permits in wait for permits. That's handled through release. And then these locks need to be unlocked in separate finally blocks that handle different segments of code. So you have to kind of rethink that. I think the Cargill article will help with that too. Keep in mind the Cargill article, of course, uses synchronized statements as opposed to rantrant locks, but the basic ideas are very similar. All right, let's now go look at some other problems. You don't need to check to see if M permits is less than 0. this lock is being held correctly, but it's never released in this method. So make sure that you do that and make sure that you always release that lock, even if an exception occurs. So that'll give you some hints about how to do sort of try finally. Make sure you use a while loop when you call a wait. That's one of the fundamental principles of condition objects. I think we've talked about that a number of times. I know it appears in the video a number of times. So please get in the habit of using a wait in a while loop, and also use the mReleased field here, not whether the wait queue contains the waiter. That's the wrong condition to check for. And again, please don't delete or decrement, I should say decrement. Please don't decrement M permits here. That logic belongs in the release method that should come later, which we'll talk about in a minute. This particular lock is being unlocked multiple times. The monitor lock's being unlocked twice. That's a very subtle bug. That's one of the downsides of using reentrant locks, is you get yourselves into trouble. You'd have a harder time doing that with a monitor, built-in monitor locks, intrinsic lock with synchronized statements or synchronized methods. But with reentrant lock, you can do those kind of things. So be on your guard for that. And this finally block is in the wrong place. Again, we're just unlocking things too many times. You need to rearrange the ordering here so it's better. And you don't need to have this go at the end of the method. It needs to go at the end of the catch clause. So this catch clause up here is where that needs to go. So some more problems. There's no reason for you to call try to get permit unlocked from wait for permit. We got to wait for permit because try to get permit unlocked didn't get the permit. And since we had the monitor lock held, nothing will have changed in the meantime. So you don't need to make that call again. Please don't acquire the monitor lock first. Please don't call the lock method within the try block. Move it before the try block. And then all this stuff here, that should have been done or would have been done if you implemented it correctly much earlier in try to get permits unlocked. So it doesn't go there. Add should be in a try block. Always, always, always call unlock in a finally block. There are certain situations where it's not strictly necessary, but you will thank me at some point in your lives if you get in the habit of doing that, because when you refactor your code and allow an exception to be thrown, life will be much better if you release the lock. And you definitely don't want to be calling a wait uninterruptedly. You want to be calling a wait, and you always want to call it in a loop. And you also want to call it in a way that waits on the proper condition, which would be while waiter, mReleased is false or whatever. Lots of code is missing here in the catch clause, so you have to make sure that you think carefully about how to handle that as well. And that's all described in my walkthrough video for the specific notification pattern applied to the fair semaphore example. Yet more problems. We don't need an interrupted flag and wait for permit. Don't call unlock. Don't call unlock is the first thing in there. Otherwise, everything below it's going to be a race condition. It'll be a race condition city. So bad things will happen. There's no need to call try to get permit unlocked. That is unnecessary. That was called much earlier in the calls chain. Not sure why we're signaling here. Wait for permit doesn't signal. It waits, not signals. Release signals, not wait for permit. Unlocking here is the wrong place to unlock. Lots of code is missing in the interrupted exception. Unclear why we're awaiting uninterruptedly. Never use wait uninterruptedly in any of the wait for permit calls. Make sure that you lock things properly before you access shared state, shared mutable state like the queue. And also, please make sure that you check the return value of remove in order to be able to decide whether to call release or not. And so there's just all kinds of things here, unlocking the wrong locks, etc. Very confused. Please go back and watch the videos carefully. Don't mix and match with synchronized and reentrant locks. That's a problem. And if you do increment stuff, make sure that you hold locks properly. All right, at long last, we're now moving into release. And here, again, please always, 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 always call your unlocks in a finally block. Unfortunately, this code is calling unlock in a finally block, but it's doing unlock once, not in a finally block, and it's unlocking the lock again in a finally block. So it's unlocking the lock twice. That'll cause no end of trouble. Here's a subtle thing. Please refactor your code so that the monitor lock is not held for the entire release method, only for the part where you're accessing the state of the fair semaphore CO object. So if you have to think about that a little bit. It's really cool when you finally understand how it works. It's a very cool optimization. This code is calling unlock way too soon. And this code is calling unlock, having not locked the waiter lock in the first place. So that's going to be a problem. And oddly enough, because unlock is called way too soon, then when available permits is incremented, there's a race condition. So beware of that as well. You have to make sure that you hold the lock over the right duration. And that may take some clever conditional expressions on your part. Let's see. Always call unlock in a finally block. I know I sound like a broken record, but please do that. I'm not sure what get and increment is doing here. Please just be using regular old ints with the right qualifiers. So you don't need all this stuff. Again, always call unlock in a finally block. This particular code, as you can see, is unlocking and then accessing the local state. So anytime you access local state with the lock released, that's going to incur a race condition. We don't like that. That's bad. Sometimes the unit test catches it, sometimes it won't, but it's almost always going to be a problem at some point. Okay, so those are some of the problems that I found, or that's the bulk of the problems I found when reviewing the fair semaphore CO implementations. Let's now turn our attention to the Palantiri manager part. So first, make sure you look carefully and think carefully about what we're doing. We're trying to implement a concurrent hash map. So you have to make sure you use the right method to create a concurrent hash map. And this, of course, is creating just a hash map, not a concurrent hash map. Down here, we have sort of a different problem. We're initializing the concurrent hash map twice, and that's unnecessary. You're just creating extra work for no benefit whatsoever. So this guy should go away. There's no need to have a try-catch block here. There's no need to throw a cancellation exception. I'm not sure why that's happening or why someone would want to do that, but don't do that. You don't need to do that. So don't use a try-catch block. Please use key set instead of entry set. You'll see when you do that, the code gets a little bit cleaner and shorter and easier to read. So there's no need to use the entry set. You're not getting any value from that. Also, and I know this is hard for people who've been learning Java functional programming, I very much recommend not using streams, especially the way they're being used here. This code has got race conditions galore because calls like get key and get value and so on are not going to be thread safe. Or even if they are thread safe, they're split across multiple calls, so they're not atomic. So instead of trying to use streams, instead what you want to do is you want to just have this nested loop where you have a forever loop, which is like for open paren, semicolon, semicolon, close paren, followed by a loop that just loops through the concurrent hash map using the 3-parameter version of replace. And using the 3-parameter version is important. That's the atomic check then act version. Make sure that you acquire the Palantiri before you do anything else. Do not pass go. Do not collect $200 until you have successfully acquired that semaphore. So that needs to go first. And you don't want to be calling this code here. Don't be calling the 2-parameter version of put or replace within the acquire method. Here's some more issues with acquire. You need to put a forever loop outside of the inner loop. Get rid of the entry set here. So I should say that again. Getting a little bit verbose, but use key set, not entry set. And another reason to do that, don't use get value followed by replace. The whole purpose of using the concurrent hash map is to take advantage of its concurrent check then act semantics, as we talk about in the videos describing the 3-parameter version of replace. That's the whole beauty of this thing, because it's atomic. And for goodness sakes, please don't be releasing the semaphore at the end of a quire. That totally defeats the purpose of having a semaphore. The semaphore is there to keep track of the number of Palantiri that are currently in use or currently available, depending on your point of view. And if you call release, then that just confuses the heck out of the system, and many other things will go wrong at that point. Speaking of release, here's release on the Palantiri manager. First and foremost, make sure you always check to see if it's null before you do anything else. And then you have to check the return value of replace or put if you use put. And only if it returns Boolean false do you call release. Otherwise, you want to throw an exception. This code had like this catch clause here for null pointer exception, I suppose, because it wasn't checking to see if Palantir was null. So do that check. Don't rely on exception handling. It's a very expensive and confusing way to do that. Other things, I don't think anybody did it in this class, but I've seen people use the 3-parameter version of replace in release. And you don't want to do that because you don't want to conditionally update the value. You want to unilaterally update the value. You want to say, make that value true, make it available. And so you need to use the 2-parameter version. If you have questions about 2-parameter versus 3-parameter version of replace for concurrent hash map, I'd be happy to answer those questions. Okay, so that was the end of the discussion of frequently made mistakes for assignment 3B. As you can see, some people have a fair amount of work left to do to fix things, especially the wait for permit part. And if you have any questions, I would be happy to take them now.